We recorded the systolic blood pressure in millimeters of mercury of 20 students, and here you can already see the collected values. For these data, we will now create a histogram.
At this point, you may wish to pause the video and try creating the histogram yourself.
Before we can draw the histogram, the values of our metric variable need to be grouped into classes. We first need to decide how many classes to use and how to define them. A common rule of thumb for the number of classes is the square root of the sample size. In our case, the square root of 20 is approximately 4.5. So we would create a histogram with 4 to 5 classes. For this example, we will use 5 classes with the following boundaries: from 135 to 145, from 145 to 155, and so on. We also need to decide which class the boundary values belong to. Let's assume that each boundary belongs to the next higher class, meaning we use a square bracket on the left and a round bracket on the right. This ensures that the classes are clearly defined. Now we can assign each observation to its class. Using the ordered list of values, we can directly determine the absolute frequencies. Class 135, 145, 6 values. Class 145, 155, 2 values. Class 155, 165, 5 values. Class 165, 175, 4 values. Class 175, 185, 3 values. All the preparatory steps are now complete, and we can draw the histogram. On the x-axis, we plot the systolic blood pressure in millimeters of mercury. On the y-axis, we plot the absolute frequency. For the systolic blood pressure, we mark the class boundaries. The absolute frequency ranges from 0 up to 6. Now we can draw the bars. For class 1, draw a bar with a height of 6. For class 2, a bar with a height of 2. For class 3, a bar with a height of 5. For class 4, a bar with a height of 4, and for the final class, a bar with a height of 3. With that, our histogram is complete.